Hi everybody, this is your instructor Ashish. I am making this video for chapter 4, which is covered in the modules. So if we go to the module screen, you may see we have week 1, week 2, week 3, so on. Every week we cover one module. For chapter 4, we are covering that in week 8 and week 9. So chapter 8 requires you to do this quiz as well as this discussion, and week 9 requires you to do some coding for the assignment project. So after making this video, I'll be posting it just like I have done for the previous weeks, such as here for week 7 I did a chapter 3 video lecture and assignment help. So for week 8 you will see assignment aid link, as well as for week 9 the chapter 4 is about control structure. So if we go to our online book, this is the chapter we are talking about here. You will be we'll be learning about the control statements, and there are quite a few of control statements. So there is two chapters dedicated to control statements, the chapter 4 and 5. Chapter 4 is part 1 of the control statements. We'll also be learning about the assignment statements or assignment operator and the plus plus and minus minus operator. So these are the items we'll be learning. We'll learn about basic program problem solving techniques, just to get your mind going of how a programmer should think when he or she is addressing a problem. We will develop algorithm using the process of top down stepwise refinement. We'll use the if and if else selection statement to choose between alternative actions. We'll use the while iteration statement to execute statements in a program repeatedly. You can We'll learn about the counter control iterations and sentinel control iterations. We'll learn about the compounds assignment operator and the increment and decrement operator, and we'll learn about the portability of primitive data types very briefly. So here is the table of content for this chapter. In this chapter, we'll be primarily learning about the control statements. And control statement means when you're writing a program, the program writes from executes from top to bottom, unless and until you introduce a control statement. There are two kinds of control statements in every programming language. One is for decision making, and which is where the if statement comes into picture, and iteration statements or iterations control statements, which is where the while statement comes into picture. So these are what we'll be learning in this chapter. um, like a procedure for solving a problem in terms of the actions to execute and the order in which those actions execute. So this is what we have at the very crux of any computing problem that we are solving, where we need to know what actions we need to do and in which order. So let's look at it. Consider the rise and shine algorithm. So what's the steps that a person takes, and in which order does a person takes after he or she gets up out of the bed? Get out of the bed, take off pajamas, take shower, get dressed, eat breakfast, and carpool to work. So he's getting out of the bed, taking off the pajama, and then he's taking a shower, putting on new dress. He's eating breakfast and going carpooling to the work. Now, if you think about it, compared to the other executive, he gets out of the bed, takes off pajama, get dressed, and then takes a shower, and then he eats breakfast and carpool to work. What has happened here? The number 3 and 4 compared to the first one, they are swapped. They are reversed. So you are saying take off the pajama, get dressed, take shower, eat breakfast, and carpool to work. What will happen in this case? Our executive shows up for work soaking wet because he dressed up and then he took a shower. So specifying the order in which the actions execute in a program is called program structure. And this chapter investigates program controls using Java control statements, as I was saying you earlier. What is pseudocode? Pseudocode is a way of a problem solving approach. Pseudocode means you're not writing code, but you're just articulating your work in a manner that is readable in English. And you also are using some kind of structure to display how your code will work. Okay, there is another way of writing pseudocode, which is utilizing some flowcharts. And flowchart helps you picturize what's coming in, what's going out, and what calculations are involved in your work. So this is pseudocode. This is the problem solving approach that everybody takes. And when the problem is simple, you don't need a whole lot of thinking, but when the problems are complex, you need to break it down. You break it and you solve it slowly, steadily to accomplish your final outcome. So, why do we need control structures? Well, before Java and other programming languages started using control structure, there used to be a statement called go to statement, whereby you can just say, go to a particular point in my code, and then from there you can jump anywhere, top, bottom, wherever. That was not the best way of solving a problem, because the code would be so difficult to comprehend and it goes out of control very quickly. So that's when the control statements came into picture, where you are doing structured programming and you are writing code without go to statements. You have a systematic way of writing code. It executes in the sequence, and you have some selection statements such as if else, and you have some iteration statements where you can accomplish exactly the same thing that you could do with go to statement, but your code is very easy to learn. So that's basically the historical point of view of why we need control statements. The structure sequence structure in Java, so basically if you have UML provides us an ability to draw a picture, which is one of the ways that you can write your pseudocode. And a black filled circle is start point. Then you have two actions being happening. You're saying add grade to total and add I to counter, which is something like this. And then you have the end thing that depicted by the black filled in circle with a hollow circle, and then you have the arrows pointing, which allows you to see how my activities are taking place in what order, what happens first and what happens next, which is what is explained right here. So what kind of selection statement do we have? I In my personal lectures I use the word decision making more than selection statement. So you have a whole variety of decision making statements or selection statements available in Java, just like any other programming language. You can use the very basic if statement, where you're saying if a condition is met, then you perform an action, otherwise, you skip it. Um, you can use if else statement, where you can say if a particular condition met, then do something else, do something else. So you have a two thing going. You can also use the switch statement. The switch statement allows us to have if the state is California, do this. If the state is Massachusetts, do this. If the state is Tennessee, do this. If the state is Mississippi, do this. Where you can have many, 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 many conditions depicted very, very clearly using switch statement. By the way, you can also use if else if statement, which is a combination of if only, along with if and else if to do the same thing, whereby you're not saying if it is heads do this else do this. So you're not saying just oh, if and else is only possible when you have two outcomes. No, what if your outcome is more than two? You can still use if else statement, what we call if else if statement. Okay, so if is a single selection statement, if else is a double selection statement, and switch is a multiple selection statement. Now kindly understand, switch is not the only way you can implement multiple selection statement. You can also use if else if, as we'll be learning later. Now what about the iteration statements? Well, iteration statements also, all the programming language nowadays have very similar way of doing these things, because what we have as of today are all the different iteration statements or selection statements. They allow us to solve any programming problem. So whether it is Java, VB, C++, or any other programming language, you have the same set of uh, selection statement as well as iteration statement. So in iteration statement, Java provides us with while, do while, for, and enhanced for, a little more different way of doing for. So these are the varieties that we have available. In this chapter, we are only going to work on the while statement. Um, the other iteration statements are covered in the subsequent chapter. The Appendix C has a complete list of the Java keywords that appear, in this book, as well as that you should avoid, because some of these words are reserved, so we can't use it. We can't declare a variable called while, because that won't work. While has a significant meaning in Java. So that's what we have learned. The summary of control statements: we have single entry, single exit control statements make it easy to build program. We simply connect the exit points of one to the entry point of the next. We call this control statement stacking. and control statement nesting, where we have more than one condition to test. We'll be coming across these topics subsequently. These are some theoretical points to understand, and not to understand in terms of Java, but to understand in terms of how a programmer will solve a problem. Because at the very basic of any programming language, you have three things that you need to worry about: how the variables work, how to declare variable, how to use them, what are the different data types available. The second thing that you need to know about is a selection statement. How do I make a if else statement? How do I do some decision making? And the third thing that you need to worry about is how do I execute a iteration? These three things make the fundamentals of any programming language. So how do we use the if statement? Here is an pseudocode. If the student's grade is greater than or equal to 60, then print passed. So this is what we are asked to do. If the student grade is greater than or equal to 60, then you display an outcome. So here I have an online Java editor, and this is as good as your Eclipse, but it allows me to do something very simple. So we can say int grade equal to 65, okay, and we'll say if grade is greater than equal to 60, then I would like to display something to my user. I will just use an open curly brace, and the close curly brace comes up, and we'll say system dot out dot println you have passed this course, or whatever, and we always use semicolon in the end to end the coding statement. So this program is using if statement, and it'll only work if the grade is more than 60. Is my grade more than 60? Yeah, I'm declaring a variable called int, called grade, and its data type is int, and I'm giving a value 65. Since 65 is greater than 60, is my line 8 going to run? You bet, it will run, and it will display the output. What's happening here? The greater than equal to sign. This is one of the ways Java allows us to write a condition to compare one with another. So we are saying, hey, if the grade which is on the left is greater than or equal to 60, then display the output. So instead of this, I can also use just greater than, which is another way. We can also use less than. We can also use less than equal to, and we can also use not equal to. These are the different symbols that you should remember, and they are duly noted in your textbook. So as of now, we'll just say greater than equal to, and when we run this, we hope to see the you have passed this course. When we are running, it says you have passed this course. What if my grade is 5, and when I run it, do you think 5 is greater than 60? No, and therefore nothing comes out, because we are just printing when something is true and nothing else. So this is the code, and here is the UML statement. So if the grade is more than equal to 60, then we are printing, otherwise we just get to the end. What is this diamond? Diamond is the universal symbol for depicting a decision making. A diamond is shown where you are making a decision, and you are displaying you are doing one thing or the other. So let's continue on with if else statement. If the student grade is greater than or equal to 60, we say you have passed, otherwise we want to display fail. Here's what we are having. We have a if area, and we have a else area. So let's continue with our code. We are saying, hey, if the grade is more than or equal to 60, then we will display you have passed. Otherwise, we will display you did not pass this class. So we will just say you did not pass this course, okay, something like that. So given that my grade is, let's just say 5, I scored 5, is my grade 5 greater than 60? No. So therefore this area, the if area, won't work, the else will work. Let me just fix my little mistake. And what do you expect to print? Do you expect you have passed this score, or you expect you did not pass this course? Let's run. I think it is going to be you did not pass this course. And given that, please excuse me while typing, I had put the semicolon in the wrong location. And given that my grade was 5, I am seeing you did not pass this course. What if I make it 65 and run it? If I make it 65, it says you have passed this course. You see in the bottom where I'm showing you. So we can use if else statement to do one thing or another thing. So If you are displaying if else statement, basically this is the if else if statement where you are saying if the grade is greater than 60, then print passed. If otherwise, we are not doing anything. It seems like this is not the right UML diagram for if else statement, but nevertheless, I do want to mention another thing where when you are writing if else statement, always use these curly braces, because if you're not using curly braces, then it can make your project or your code extremely complicated. Here, my code will work just fine because I have only one line that I am doing when I am checking for condition. If my grade is more than or equal to 60, I want to do this, otherwise I want to do this. Now if I would like to display something else, that system.out.println good job, okay, or something like that. If I want to display something like this, then it's not going to work because I'm not using the curly braces. Without the curly braces, only the next code executes. So if we run this, we might run into some problem. But let's see. It says else without if. It's saying your if statement kind of ends here, and you are writing something, system.out.println good job. So it is just saying this is fine and all, but this else is dangling. Dangling means it is not associated with a if clause. So therefore, what we need to do is whenever we are writing a if else statement, we will always have a if area as well as a else area denoted very clearly with these curly braces. So this is nice and clean code. Everybody understands what we want to do if the condition is true and if the condition is false. Here, said you have passed this course, good job. There you go. This is what we wanted to accomplish, and it is exactly what it's been doing. Okay, what about nested if else? Here is what I was trying to explain earlier, that this is a multiple selection statement whereby you are not confined to saying this or that. You are saying if this is A, do this, if this is B, do this, if this is C, do this, and all that, which can be done using if else statement as well as switch statement. Okay, so here is the example of the pseudo code for if the score grade is greater than equal to 90, print A, else check. If the grade is greater than equal to 80, then print B, else this and this. So this is how you will write. You're basically enclosing your other if else statement inside the other. Okay? So be very careful when you're writing. So we will write like this. So if your grade is more than 90, then we would like to display A. Say for example, let's keeping it very simple. Otherwise, what we need to do is we can't just say you have to pass this, you failed this course. We need to say if grade is greater than equal to 80, then we want to display B. So let's just copy paste this. We will say we would like to display B. Okay. Else, we would like to further again check it. So we are saying, we will not just say it is pass or fail. We are going to say if your grade is more than 90, we know you scored an A, otherwise you scored a B. So what we are doing is we are just adding another condition, and if it is not more than 90, then we check is it more than 80. If it is more than 80, we display the B grade. Otherwise, we check if it is more than 70 and we display the C grade. So this is what is happening here. We are nesting one inside another, and your code will look kind of balanced if you are looking at it. So the textbook asks us to check until 60 and then displays a F. So if it is 60, then we will do D, else we will say system.out.println F. That means the student did not pass the course as expected because he or she did score less than 60. So here we have code runs top to bottom, left to right. This if I may, you see that this is the if statement And this whole thing is the enclosed else statement. So we are saying if it is more than 90, display A. Don't worry about the else. Just get to this curly brace, get to the end of the main method, and finish the class. That means this is how it will run. In my case, with the value 65, it will run 6. It will say, 65 is not more than 90. Then it will go to else, run line 8. Then it will run line 9 and say, hey, is 65 more than 80? No. Then it will run to the else, which is 11. And it will go inside and say, hey, is the grade 65 more than 70? No. Then it will jump over to 14. And then it will go inside and say, hey, is 65 more than 60? And it will say, yes. It's going to run this. It will go to this one, skip over the else because only one of the two can run. It will go here, 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 and it will end. So this is how it will work. Let's just print it. And when we execute it, it prints the letter alphabet D, which is to say the grade is D. Okay, so hopefully this has clarified what I'm trying to convey with this particular code that I have written. And one can write the code like this as the textbook says, or you can align it as well. So here there is a slight difference. Here they have written if else, and then there is a if inside, and then else, and there is a if inside, and there is an else, and there is a if inside. You're welcome to do it like this, or you can flatten it by using this else if, which is what I was showing you earlier. So if you were to do else if, you don't have too many curly braces, you are combining some of them. So you may have something like this. You're saying I have if, else if, and then you have another else if. So your code will look more balanced, nothing incorrect about it, or balance in a sense it will look more cleaner to the eyes, and it makes a lot of importance, folks, when you are having to write your code, because the spacing makes a big difference, and your code doesn't look complicated. So it's a very important point when you're working in an organization, that the code looks cleaner is one of the key things that your peers will say when they are reviewing your code. So here we have if else statement whereby we have reduced the amount of complexity to what we had earlier, and you can naturally see that the number of closing curly braces are far less than before. So we are saying if it is more than 90, go inside and print A and skip everything else. Otherwise, check is it more than 80, print B and skip everything else. Otherwise, check if it is more than 70 or equal to 70 and print this or this. Otherwise, print F. What is this else portion? This is the last one, right? So if the value you entered is, let's say, 5, if it is 5, obviously it will display F. This is called the else portion. So one can avoid it. I can say, yeah, I'm not going to have this. I'm just going to delete it. What's going to happen if I enter the grade as 5? Nothing will print. Therefore, we should not avoid else. We should always have else available, which is makes it very clear what's going to happen in all possible circumstances. That is what we call avoiding the dangling else problem. Okay, so this is what's mentioned in our book here. If you, as I already mentioned, if the if statement normally executes only one statement in its body, if to include several statements in the body of an if or else statement, enclose the statement in braces or curly brackets. Okay, statements contained in braces form a block. So this is a block of code which is just one line, but here it's much clearer. You have two lines being printed. I've already talked about it in my previous discussion when we were looking at the code, so I'll keep it short. But by having these curly braces, you make your code readable. It's an extremely important thing. If we do not put the curly braces, we will have weird outcomes, and it will require you to study your code. It can cause a lot of problems. It will not cause a syntax error all the time. It may cause a logic error. And a logic error is something that you cannot easily find. It will take you a while to understand what's happening. So therefore, I would highly request When you are writing if else statement, always use the open curly brace and closing curly brace. We also have a conditional operator which does the same job as if else statement. So if you have to display something, you can, rather than doing all this, although this code has matured enough since we started this video, if I have a 65 as my grade, I can just use system.out.println grade more than equal to 60, and then we can use question mark as passed. Now you can see that we can use failed. So let's just say we are talking about only pass or fail. So if the score is more than 65 or 60, you passed somehow, otherwise you failed. So this is how it works. You are checking for a condition and displaying passed or failed depending on one or the two. The other symbol is a question mark. The first symbol is the question mark and the other symbol is a colon, not a semicolon, a colon. And every line in Java ends with a semicolon. So here we go. This is going to display passed because the value 65 is more than 60. We don't have to do a for else or anything. We are just simply using the conditional operator to display one or the other value. Okay, this is a simple way, good way to do some calculations when you are needing to do some quick calculation. Here's the example that the textbook uses about a class called student class that has some features similar to those of the account class we discussed last time. You are storing the name and the average. So here is a constructor on line 8. Starting at line 8, going all the way until 18, you are storing the name in the class level variable and you are checking the average before you are saving it. Then you have a setter method for name and a getter method for name. You are setting it and you are getting it. And then you have a set average method where you are saying if the value coming in is more than 0 and less than equal to 100, then you are setting the average, because average usually is never more than 100 or less than 0. And then you are having a getter method for average. So you have a letter grade where you are saying, okay, the letter grade is blank. And then depending on the average, you are returning a string data type variable. So that could be A or B or C or D. And you have a return statement to return the value. So this is what's happening. And this is what's been explained here in a very practical concept, how we can use the if statement to display one or the other value. And here is a student test class where they are invoking or utilizing the student class, creating two instances of the student class, and then they are displaying the average for those two, or excuse me, displaying the letter grade for those two by calling the student name as well as the letter grade to saying Jane Green's letter grade is A and John Blue's letter grade is C in this example here. Okay. So while until the previous page that you noticed, we are having the when we are writing the code, they write a student class and then they write a student test class to sort of make use of the student class. So this is fine. You can do that. You can also include the public static void main directly in the student class and utilize whatever you have done to execute that student class itself. So I don't want you to feel that you always have to have two classes, one for the code and another to test it. Because in this chapter's assignment, you're asked to do everything in just one class, which actually makes it easier. So I wanted to go back and tell about this to you very quickly. About the iteration statements, we are going to learn about while statements. So while there are more items on my shopping list, purchase next item and cross it off my list. This is what we would do if we have gone to a grocery store to buy a bunch of stuff. How do we do this in Java? Well, you can say while the product I have an int variable called product, I'm giving it a value 3. And then I'm saying while the product is less than equal to 100, the product multiply by 3 times. So if its value is 3, 3 times 3 will become 9, 9 times 3 become 27, and so on. So it's going to keep repeating and repeating and repeating these three lines until the product value exceeds 100. So it will start with 3. Then next time we are saying, hey, my product, your value is going to be your previous value times 3, which will be 9. Then is 9 less than equal to 100? You bet. It'll go again 9. Then the product will become 3 times previous value 9. So it'll become 27 and it'll go back and say 27, are you less than equal to 100? And it'll say yes. Then 27 will the line will say product equal to 3 times 27, which is 81. It'll go back again and say, hey 81, are you less than equal to 100? It'll say yes. Then the new value for product will be 3 times 81, which is 243. Then it'll go again and say, hey 243, are you more than less than equal to 100? It'll say no, I am more, and therefore it'll go right here. It will not run this line ever again. This is a while statement, UML activity diagram. So this is how you would write. And UML is a uniform modeling language. It's also universal. So no matter what programming language you may see in a professional enterprise environment, UML is used to always display the pseudocode. So kindly understand what you're learning here is for your own benefit. So here is the while loop that we are running again and again, what we learned in the previous picture. What is counter controlled and sentinel control? So there are a couple of things we'll be learning about it. Counter control is when you know how many times you need to run a loop or to do an iteration. That is called a counter control. You have a counter in mind. If you're asked to run, calculate grade for 10 students, the 10 is your counter. You know I have to run it 10 times. Okay, when you know about the definitive number of iterations you need to execute, we are going to use counter control. Whenever you are running a loop, you also need to think about like, okay, I need to calculate the total of something. So you need to worry about two kinds of things. You need to worry about the how many times I need to run, how many times have I run it, and am I calculating the grand total. Okay, so total and counter are kind of two important concepts. Basically, if you are in the Kroger store and you're buying some stuff, you will, as you are paying for it, your bill and the software that is used to calculate the bill keeps track of two things: your total amount, which prints on your bill, and how many items you purchase, it also prints. So when you are thinking about iteration, kindly think about the total as well as counter. This is very important. While grade counter is less than or equal to 10, prompt the user to enter the next grade, input the next grade, add the grade to the total, and add 1 to the counter, and go back again. So this is what you are doing. After you have done, set the class average to the total divided by 10, because we are asked to run it 10 times, and print the class average. So this is how you would write the code. You would say, okay, I'm going to have my scanner with the system.in. I'm going to have a variable which is total and grade counter starting with 1. So you're saying, hey, I have this while loop. It's going to run however many times. As long as the grade counter is less than 10, it will run. It's going to display enter grade, take an integer, and store it into the grade for, let's say, student 1. Then it'll say I have to keep track of the total of all the grades. So we'll say total equal to total plus grade, and then we'll increase the grade counter by 1. So that it'll say, okay, next 2 less than 10, yes, do the job. Increase the grade counter. Is 3 less than 10? Yes, do the job. After the 10, it'll say, is 10 less than or equal to 10? You bet. 10 is equal to 10. The loop still goes. It'll go here, enter the grade, get the value, add the grand total, and then the grade counter will increment by 1. It'll say, hey, 11, are you less than equal to 10? And no, it will terminate. It'll come here, take the total, divide it by 10, find the average, and display the class average. So this is how it will run. Because we knew that we have to run the loop 10 times, we use the counter controlled approach to write the code for this problem that you are seeing on the monitor. Okay. Now kindly notice that we have this main method which is on line 6, and then we declared in total on line 11 and grade counter on line 12. And then we have this while loop where we are using this total to keep track of the total of all the student, and grade counter is also declared. And we can use this total down below where we are saying total divided by 10 will result into average. So we are using some variables which are declared directly in the main method and are being manipulated inside the while loop. Okay, kindly read this because this is a important area, how what I just described to you. When we are doing an operation like this, total plus grade, uh, your grade value is being added to the previous total and the new value is deposited here. Now, if in case you enter the grade as 1 billion, or 700,000 billion, then the value that we can deposit into this total, which is an integer, will exceed the amount of memory space allocated by the computer uh, to a integer variable. So it will result into overflow, which is pretty much like, if you are filling a bottle of water, after filling up it overflows, right? So it's going to result into an error called overflow error, because you have given a certain amount of memory for every integer variable, and if you try to put in a value which is far exceeds the highest number one can store in an integer variable, it will result into this into this error called arithmetic overflow error. Okay. uh, the maximum and minimum values that you can store in the int variable are inside this integer dot min value and integer dot max value. You can actually display it by using system.out.println, because it's a good thing for you to know how much I can store. Okay. Now, when we are getting the value from the user, we always use, input.nextInt or something like that. And if the user enters a reasonable value, it's no problem. We can just simply store it. But if the value is far too big, it will fail our application. Similarly, we need to be careful that if we need to store uh, decimal points, then we should not ask next int. We should not use int grade. We should use decimal grade, something like that. Otherwise, we will truncate. If you are doing like this and if you enter 10.5 on your keyboard when you're prompted, hey, guess what will store in the int grade? Only the 10. That zero point 0.5 is removed. It's called truncated. Okay, so keep those small things in mind. What about sentinel controlled iteration statement? Well, sentinel control is basically the way where you're saying, I don't know how many times I'm going to run it. So I'm going to say, if you need to terminate the application, enter a special character such as -1, which is by far the most common way of terminating a sentinel controlled iteration statement. So you will say, while the grade entered by my user is not -1, I'll be keep going and going and going and going. Okay, so you use a dummy value or some kind of flag, okay, to terminate your loop. You don't know how many times it will run, therefore it is not called counter control statement or counter control iteration. It is called sentinel, because there is a value that I will check in my code, and if it is that particular value, I will terminate my iteration. So if you are given a problem that says develop a class averaging program that processes grade for an arbitrary number of students each time it runs, arbitrary. So therefore we need to keep account of that. Okay. While the user has not entered the sentinel, add the grade, then add 1 to the grade counter, prompt the user to enter the next grade and input the next grade. So we'll be keep doing this, and finally we'll calculate and print the output. So here is the overall pseudocode that we'll be doing. We'll initialize total to 0, we'll initialize counter to 0, we will prompt the user to enter the first grade. User will input the first grade while the user has not entered the sentinel. So when we are prompting the user to enter the grade, we'll say, please enter the grade for the student. If you need to terminate, enter -1 or something like that. So we'll tell the user what is the sentinel that we are using. Therefore, if he or she wants to terminate right away, go for it, no problem. But if the user has entered a proper grade, then we will add the grade to the running total. Now increase the counter because we need to calculate the average, right? So we need to know how many times our while loop has run. Then we'll prompt the user again to enter the next grade and input the next grade into a variable, check if it is sentinel or not, and so on. And if the counter is not equal to 0, that means you have at least one time where user has entered some value, then we will display the average. Otherwise, we'll say, hey, you didn't even enter anything. When we asked you to enter something first time, you just entered the sentinel and immediately terminated the loop. And here is the code for that. We are going to say enter grade or -1 to quit. So we are having a very simple code here. We have import java.util.scanner, public class average, public static void main, and all of the code is written inside the public static void main or the main method, if I may call it that way. We're having a scanner instance called input. We have our total given 0, grade counter is also 0, and then we'll say enter grade or -1 to quit. The user will enter an integer if while the grade is not equal to -1. So we are saying the grade is not equal to -1, then go and do the job. So if I entered 15, is 15 not equal to -1? You bet, 15 is not equal to -1. It is different. Then we'll say total is equal to the old value, which is 0 plus 15. And grade counter, which was 0, will become 0 plus 1 is 1. Then we again ask the user, before we go back in the top, we'll say, hey, enter grade of -1 to quit. User enter something, we'll say, hey, did you enter -1? If -1 is not equal to -1, no, it is equal and it will break out. But if you enter 10, 10 is not equal to -1, that means this thing which is written in the parenthesis will result true. While true, keep going. While true, keep going. And we are checking if the grade counter is not equal to 0. That means if the grade counter, at least one grade was entered by the user, which is what's noted here, then that means we will go and run this if statement area where we are dividing the total by grade counter and displaying the output. Why in the world are we using this double? Well, folks, we are doing a typecast. We are converting this integer into a double so that the value is not truncated. If the value in total is 100 and in the grade counter it's 7, when you divide 100 by 7, it's going to be a fraction. It's going to have decimal values. And if we don't use this double, then that means the value will be converted into an integer, and that's what will be stored in average. Therefore, we are using this double here to say whatever comes out of this calculation here, please convert it into a double and store it into a double average. And that's what we are displaying back to the user. Okay. And the value that we'll display for the class average in this dummy statements that are written down below, you will see it is a double. You are having 85.67. Program logic for sentinel control iteration versus counter control iteration. So pretty much what we have done, where we are, if we know how many times we need to run, we'll use counter control. If we don't know how many times we need to run, we'll use sentinel control. Always, always, always use the curly braces while you are writing while statement, uh, because if you don't do it, then only the one next line is considered part of the while statement and everything else will be not considered part of the while statement. So here you have, if you don't write the curly braces, then this while loop will just run this one line and the grade value is never changed. So what will happen? This is what we call an infinite loop. The preceding code would cause an infinite loop in the program and it will keep on going and going and going until you have to shut down your software or kill the program. This is what we call killing it so as to stop it. Now, explicitly and implicitly converting primitive types, as I was telling you folks, if we write this, then what will happen is the total divided by grade center. If total is an integer and grade center is an integer, then the output will also be an integer. And what goes into the average will be an integer. So it will be not correct. And therefore, we use this double, which you saw me speak about in the previous page, or when we were looking at the code, we use the double in after this equal to sign, so that the output that comes converted into a double, which is called explicit typecasting. We are typecasting it and storing it into the average. Okay, this is an important thing, otherwise it will result into um, errors which are called logical error. You will not see any squiggly line. That's the syntax error. Your code will run, but it will run in mysterious ways. Okay, therefore, we should always be careful about what is the data type I'm using, and use explicit conversion or typecast your values into the appropriate data type. Okay, we'll be talking about certain operators which can be done on one parameter. Such operators are called unary operators. Okay, there are other ones called binary operators. Like, in order to use the plus sign, you need to say, if I'm writing my code, very simple, I have a grade and I have int grade for B. So let's just say this is grade A for my one class, and I have grade B. Now, if I need to have a total, then I will say grade A plus grade B. The plus operator is such that it needs two things. It adds up one with the other. There are two things I need to use the plus sign. Therefore, it is binary. Binary is the two. Okay. The unary operators are such that they only need one uh, operator, one thing in order to run. Okay. There are multiplicative operators as well, such as you have the multiply, the forward slash for divide, and the percentage sign. So we'll be learning about these very briefly. Floating point precisions, when we are displaying the output, you can use percent dot 2f to display two places after decimal as need be. Kindly go through this, learn some more about these things that we are learning. Nested control statements. We did talk about this when we were going through the grade of A, B, C, D, and F. So when we are having one control statements inside another, we call it nested. They are nested within one another. You will also have a scenario where you are using a iteration statement, and inside the iteration statement you are using a if statement. So, and this is the thing, probably they have it here, where you're saying while the student counter is less than or equal to 10, prompt the user to enter the next exam result, input the next exam result, that means store it into an int variable, and use an if statement. So here we have while statement, which is what we learn as the iteration statement, and then we have the if statement, which is what we learn as the selection statement or decision making statement. So we have one control statement inside another control statement. Okay, let's look at the code for this, because this is just the same thing. Here we have our import statement, then we have our class name called analysis, we have our public static void main, then we create a scanner instance, then we have passes equal to 0, failures equal to 0, and student counter is starting with 1. As long as the student counter is less than or equal to 10, we keep running this while loop. Where does the while loop start and end? Watch for those opening and closing braces, because if you're coding in Eclipse or any other software, you try to indent your code so you can make it readable. We are saying system.out.print enter result 1 equal to pass and 2 equal to fail. User will enter 1 or 2, and we'll say if the result is equal to 1, then we increment the pass by 1, and otherwise we increment the failure by 1. Now, one thing to mind and watch out here is when we are checking for equality, we have to use double equal to sign, equal to equal to. So we are saying the result is equal to 1, Then let's increase the counter, which is used for checking or storing how many students have passed, which is passes. Otherwise, we'll increase the failure count by 1. Also, before we go to the end of the while loop, we'll say let's increase the student counter by 1, because if we don't do it, guess what will happen? If we don't do it, this will become an infinite loop. Student counter starts with 1 and you never change the value for that inside your code. That means the student counter, which is what determines when your while loop will break, will never change, and you will have a classic example of a infinite loop. After running this loop, which will run for 10 times, we are going to display the output and show the output to the user. So here we will have the output being shown to the user. Let me scroll up here, and it's a little bit of technical problem here, but hopefully we can solve it. So let's go down nice and slowly, and we will, this is the, let's go out, down. Something we have already done. I'm just having a little scrolling problem on my Mac here, so hopefully it will fix up. Otherwise, I'm just going to reopen the page and hopefully it will solve the problem. But try to understand while my page is loading, all I'm trying to mention and reinforce with you all is that we can have one control statement inside another, and that's what we call a nested control statement. Okay, so keep those things in mind as we are going through this and learning about these essential concepts. Okay, let's go down, and this is where we were. We were looking at this code, keeping track of this while loop with a student counter and incrementing it by 1. So the output that will be, if you are running this code, you are prompted for 10 times and you have to enter 10 times, and then the output will be displayed to you as how many passed and how many failed. Okay, this I apologize, there is a little flaky behavior happening on my laptop with scrolling. I hope you all are able to follow along with me. I will try to go down just a little bit. So you can see here is the output that will be generated by the software, as you can see. And if the passes is more than 8, then we are giving bonus to the instructor. Oh, that's a nice school to work at, isn't it? Now, let's go down, and then we'll go to the next page. So hopefully I can still go down to the next page. There seems to be something wrong happening. Let me just open the table of content. And it seems to be not responding, so I'm going to just close it and reopen it. So here I am blessed to have access to this ebook so that I can show it to my students. Now we were looking at chapter 4, and we were looking at this section, which is what we had done. Seems to be working fine. Let's go to the next page. We are at 4.12 section, compound operator. So when you're working on the total, as you have seen, or keeping track of how many passed and how many failed, we are always repeating the same variable name: c equal to c plus 3, passes equal to passes plus 1, something like that. We can shrink this by utilizing the compound operator called plus equal to. What it does is it increments the value of c by 3, because that's what is written here. Okay, generally we write like this: variable equal to variable operator expression, c equal to c plus 3, but we can shrink it by saying variable operator equal to expression. So here is the example: c plus equal to 7. If 3 was the value, it will become 10. Okay, if d is 5 and we are saying d is minus equal to 5, 5 minus 4 equal to 1. So these are the examples for how we can use plus equal to, minus equal to multiply something by itself, and divide equal to some divide something by itself, and percentage equal to uh, uh, find the remainder. Okay, so we can say that if the f is equal to 6, then 6 divided by 3 will be 2. Okay, if g is equal to 12, 12% equal to 9 will be, okay, if you divide 12 by 9, 9 times 1 is 9, and what's the remainder? 3. Therefore the output is 3. So percentage is the remainder operator in Java. Okay. Increment and decrement operator. You can also use these plus plus, minus minus to increment a variable, just like we were doing. Student counter equal to student counter plus 1. You can use plus plus a to increment the value of a before the line executes, or a plus plus to increment the value after the line executes. So there is something prefix and postfix. Okay, here is our code. Very simple. You can see that there is public static void main. We have a variable called c before post incrementing. We are just displaying the value of c. Then we are saying post incrementing c. When this line number 9 runs, it will still print 5, but after printing 5, after this line runs, it will increment it by 6, by 1, making it 6. Okay. In here, we are just displaying the output, which is 6. Okay. In the bottom, we have c equal to 5. We are just re-initializing the value to 5. And we are saying, hey, c before pre-incrementing. It will print c equal to 5, because that's what the value of c is. And then we are saying plus plus c. Before this line runs, plus plus will make 5 become 6, and that's what will be displayed to the user. Okay. And then we have the value of c. So these are the output that will come from pre-incrementing, post-incrementing, my apologies, and pre-incrementing. Okay, by utilizing the plus plus sign in front of the variable name, or plus plus minus minus sign, whichever the situation demands, after the name of the variable. Okay, why are we learning about these? The whole thing, my dear friends, is that these statements, they make our code become very clean. Rather than writing like this, you can simplify the whole code by writing like this. It makes it super duper clean. You can say plus plus passes, plus plus failure, plus plus student counter, even better. So it really helps simplifying how your code looks. Okay, you need to understand how these different operators that we have studied, there is a term called associativity. And what is the type? So you have plus plus operator that only works on one variable, therefore it's a unary. And postfix, it goes from right to left. You have plus plus, minus minus, plus minus, and some type in parenthesis. These will run from right to left, unary. Similarly, you have the other operators that we have studied in this chapter. They are all mentioned here. Kindly study these and try to use like a dummy code like this, so that you can practice how they actually work. Primitive types, int, double, string, these are all primitive types. They are uh, the way Java works. These primitive types, they perform exactly same on all the different operating systems, Linux, Unix, Apple, whatever you have, Windows. They all work in a similar manner. What's the benefit that we derive out of it? Portability. It is one of the things that I asked you, before as well. What makes Java so popular? Because it's the portability. It makes your code run in this similar manner on all the different operating systems. And when we are declaring these variables, the default value that is given to all of them is 0 for char, byte, start, int, long, float, and double. In instance variable of type booleans are always given a value false, and any reference variable that you have is always given a value invalid. I'm going to skip over the GUI portion because my intent here with this particular semester, with this course, Java 1 course, is to get you familiar with the fundamentals. If you have studied this, you can do it. There are some nice, very cool way of displaying, utilizing the control statement we have learned to draw some graphics. So if you are interested in that, please by all means do it. Most of the code that you need is actually written by the author, and you can use it to work with it to display something like this, or display a pattern like this. We are using if logic or if else or while statement to display like this. We're just changing the size and the dimensions and the location to print a structure like this. So if you are using a while loop and you are decrementing your size or changing the location, of where the shape has to be drawn, it will eventually become a very synchronized shape like you are seeing here, or here. It's very easy to do that. And that's the end of this chapter, folks. We are at the end of it. We learn about control statements. We learn about control structures, one being selection, another being iteration. In the selection, we learn about if, else if as well. In the iteration, we learn about while. We also learn about how we can use compound statements such as a compound operator such as plus equal to, minus equal to, star equal to. We also learn about the unary operators such as plus plus and minus minus to make our code even simpler to read. I hope this was useful. Covered pretty much everything that is part of this. The assignment for this chapter calls for 4.10 on page 156. So let's go there and then we will look at it. 4.10 is compare and contrast the if single selection statement and the while iteration statement. How are these two statements similar? How are they different? I mean, you can easily answer this. I'm looking for a very brief, simple answer. You can say if statement is used to check for a decision, and the if single selection statement is used when we need to execute something only when a particular condition is true. While iteration statement is used when we have to iterate or repeat certain lines of code, either on a sentinel basis or on a counter basis. These are the differences. What is the similarity? They both allow us to have ability to change the execution of code rather than going from top to bottom and just blindly execute. That allow us to either repeat the code or skip the code given whether we are using a selection statement or iteration statement. The 4.14 exercise calls upon what is the difference between pre-incrementing and post-incrementing a variable. The pre-incrementing and post-incrementing is nothing but, we have a variable like x, and we are going to say system dot out dot println, and we are just going to display x plus plus as follows. Okay, and then we are saying, hey, let's make the x again 10, and then we are going to display x not as plus plus but plus plus x. What is the difference between the top line and the bottom line? When we run it, we can see that the first one generates a value 10, but this plus plus x generate a value of 11. So think about it, this line changes the value of x to the next value, next number, after the line execute. What does the plus plus x pre-incrementing does? It increases the value of x to the next number by 1 before executing the line. So that's what I'm looking for when you see 4.14 as the question here. The other ones that you need to do is 4.17, gas mileage. You are asked to use a while loop here, and I want to clarify that this is saying drivers are concerned with the mileage for their mileage their automobiles get. One driver has kept track of several trips by recording the miles driven and gallons used for each tank full. Develop a Java application that will input the miles driven and gallons used both as integers for each trip. The program should calculate and display the miles per gallon obtained for each trip and print the combined miles per gallon obtained for all trips up to this point. Up to this point, okay. All averaging calculations should provide floating point result, use class scanner and sentinel controlled iteration to obtain the data from the user. So basically what we need to do is we need to display the grand total MPG as well. So we will have, you know, variables that we do. We'll say int total miles, okay, as one variable, because we need to capture the how many total he or she has driven, and int total gallons as another one, and then we will have a while loop. We'll say let's use -1 as sentinel for our code, okay. So we'll do something like this. Now this is based exactly like how it is done for the passes and fails in the previous pages of your book, and also the other ones. So I'm not doing anything different. I'm not going to write the whole code, but we are just going to say int counter equal to 1. We are just starting with counter, and we are saying we'll ask the user to enter something. So I'm just going to write a pseudocode and say let us get the miles from the user, okay, and then you'll have a while loop. So we'll say while counter is not equal to -1. I'm going to keep running this while loop, and I'm going to ask let us get the gallons from the user. Once the user enters the miles in gallons, you know, we will have int mpg equal to the miles divided by gallons variable, right? I'm writing pseudocode here, and we will display the mpg to the user, okay. Now at the same time we will add the miles entered by the user to the total miles in order to have grand total of miles, and add the gallons entered by the user to the total gallons in order to have grand total of gallons, okay. And after the while loop ends, we increase, so counter plus equal to or plus plus, so that it increases by 1 and goes back again, okay. um, Something like this, okay. Now counter is used to go through the while again, and after the while loop ends, we are going to display the grand mpg by dividing the total miles divided by total gallons, okay. This is a pseudocode I have written just to give you a point of view on how you need to write it, okay. And then you have 4.19, which is similar to what you have done, but here I just want to clarify that you will be using a while loop, and you will say int counter is equal to 4 because you are given 4 values. So you are saying, hey, when you're working at a place, you as a salesperson, you receive $200 per week. That's your base salary, but you also make 9% of anything that you sell. Okay, so a person who sells $5,000 worth of merchandise will get 200 plus 9% of 5,000 or $650. That's his or her salary. So what we are asked to do is we have been supplied with the list of items sold by each person. The value of these items are showed in this figure. We need to write a Java application that input one salesperson's item sold, how many of item 1, how many of item 2, and calculate and displays the sales average. There's no limit to the number of items that can be sold. So basically you are having to write, you will say int sales equal to 0. Okay, you are trying to capture how many items this user has sold. Okay, and then you have to write while counter is less than equal to 4, because you are running it 4 times. There are 4 types of things they can sell. And then we'll say system dot out dot println, we'll say enter the number of items sold for item number counter. Okay, something like this. And when the user enters, it will go into our sales. So you will capture the value in sales, and then you will also have int total sales to capture the amount of sales that the user has done. But if you're saying if counter is equal to 1, then number sold. Okay, counter is equal to 1, then total sales plus equal to number sold multiplied by 239.99. Okay, you are using control statements as well as the iteration statements for this code that we are writing. Okay, so if counter is equal to 1, then we use the item number 1 information. If the counter is equal to 2, then we are going to use the item number 2's information, which we will do in a little bit, like this. If it is item 1, then we do this. If item 2, we do this. If it is item 3, 129.75, 99.95, 129.75. When I'm writing the code, gentlemen, ladies, I do tend to use a lot of copy pasting because it makes writing the code pretty fast. And this is what we are doing. So basically, this is end of class, this is end of main method, and this is end of while loop, and this is end of if statement. Okay, so what you're doing is you're saying, hey, how many of first you have sold, how many of second you have sold, and after doing that, all that you need to do is display the sales commission for that salesperson. So you will say double, or you can say double commission is equal to $200, and because we need to typecast, make sure we are using double. $200 is the basic salary of this person, and then 9% is 0.09 times total sales. Okay, so this is the output, and then we'll just have to display the commission to the user using system.out.println. So this is again a pseudocode with a lot of code I've written so as to give you some pointers, but I don't want to write the whole code up top to bottom. This is an assignment. Please go to the chapter, study what I have done, and this is again pseudocode. This is not real code, but partial code, partial comments to give you point of views. Okay. If you have any questions, I'm always here to help you. My information is on the home page. I will be posting this video under week 8 and week 9, so you can study it along with the PowerPoint and the textbooks that you have. For the chapter 4, we have covered in chapter week 8 and week 9. Thank you so much. I look forward to hearing from you for any questions or any doubts you may have, so you can succeed in learning chapter 4. Thank you.